haven't got your booming voice, so how have you been?
Oh, it's working now, though. Good timing.
I haven't got the booming. Ooh, I've got the booming voice now. Thank you, Tony. Good introduction. Oh, I feel a bit short. Now, when I'm normally up on the stage in Porters, I'm like singing some sort of musical at Jane's Calamity. So if in the middle of this science I suddenly burst into a bit of Les Mis or Hamilton, just tell me to stop, really, honestly. It's fine. So today I wanted to come and tell you about 3 of my heroes, females in, I say astronomy, but I actually begged the committee if I could squeeze one of the 3 to be maybe not strictly an astronomer, but there is a connection to space, so I hope you'll forgive me for that. Okay, see if this works. So we're going to have a little game of the Xtra Factor. We're going to meet 3 potential candidates that you can vote on at the end when you decide which one you like the best, or which one's story you like the best. And we put this show together for schools because if you ask, well, let me ask you, this is a slightly skewed audience, I realise, but I do like a bit of audience interaction. Can you put your hand up and give me the name of a female scientist? Or shout it out. Yes, you sir.
Marie Curie.
Marie Curie. Who else was going to say Marie Curie? Anyone have a different one? Oh, right at the back. Rosalind Franklin, thank you, madame. Yes, but 99.9% of the time you ask people that question, Marie Curie is about the only person who comes up. So it's my mission tonight, and in my life in general, to give you a few more examples to pull upon when people tell you or ask you for a good female scientist role model. Okay? I also do a bit of research at the university about how role models are really important to get young people into science, maybe particularly underrepresented groups, which in physics, sadly, means women still, unfortunately. So, here's my first scientist. Has anyone heard of Cecilia Payne-Gaposchkin? Woo! Woo! Yeah! Thank you, Holly. So, here's our first, definitely astronomer. So, she was born in Wendover in England in 1900. She was the oldest of 3 children. Her father died when she was very young, so she had to help her mother raise the other children. But she got a scholarship to go and study at Cambridge University, where she studied physics. She was the only female on her course. She was lectured by people including Ernest Rutherford, who you might have heard of, as a famous physicist, who apparently took great delight in making sure she sat at the front of every lecture, because that was the rule for women, and then delighted in starting his lecture, "Good evening, ladies and gentlemen," much to the hilarity of the men in the room. So she was basically kind of harassed through her degree. Hopefully that does not happen anymore. But when she finished, she got inspired by a visiting lecture by Arthur Eddington, who you might know or you might have heard of. He did some really important work going to view a solar eclipse to see if Einstein's prediction of relativity was right. And he was at Cambridge lecturing about this, and it inspired Cecilia. So she went up and asked him at the end, "I want to work in astronomy, what should I do?" And he basically said, "You won't be able to do it in the UK. You have to go to America. There is no programs where women can get a degree in astronomy." So she went from Cambridge, UK, to Cambridge, Massachusetts, and she got into Redcliffe College, which was a women's liberal arts college attached to Harvard. And then eventually she got a job working at the Harvard Observatory. And you might have heard of a group of women called the Harvard Computers. So women were not allowed to be researchers, but they were allowed to do all the maths and the data analysis of the astronomy data as it came in. So that became her job, and she started doing her research there. She has some good quotes about why you should or shouldn't do science. I quite like this one. Don't do it for the fame or the money, because you won't get it. And you might not get anything else, but you must do it for the right reasons, for the love of discovery, which I think is quite inspiring. And when she produced her research, she made a massive discovery, basically, about what stars are made of. And up until that point, everybody in the scientific community believed that stars were made of the same elements as the Earth. All right, so they thought there's no reason why all the stars wouldn't be the same as what the Earth is made of. And that was what the whole scientific community thought. And her thesis said, no, I think you're wrong. We think that the sun, is the one she looked at first of all, is made mostly of hydrogen. And in fact, she had a theory that hydrogen was 1 million times more abundant in the universe than any other element. And her external examiner, the person from Princeton who was looking at her work, said, that can't possibly be right. I think you've made a mistake and you should keep that quiet if you want to get your thesis passed. And so she did. And she played that bit down and said, this probably can't be right. But then, coincidentally, 10 years later, he published a paper about the abundance of hydrogen in the universe, because by that time, the whole of science had kind of caught up with what Cecilia had shown. So it's really hard, and that's for men and women, anyone who's on the boundary of new knowledge, to try and overturn sort of scientific belief, if you like, or what they think is right. And you know you're pretty famous when you've had a pair of pants named after you, right? So there was a company who developed a pair of Cecilia Payne pants. Sadly, they've gone out of business if you're rushing to buy a pair for yourself. But she's also had an asteroid named after her now, and a volcanic crater on Venus, I think. So she has been recognised by some people, but is not really a name in common use. So you now know, when you look up at the stars tonight, it's going to be a beautiful clear night, and you wonder what they're made of. Cecilia is the person who made that first discovery. I like this. I like the sort of harsh look she's giving here, like this might be how she looked at the supervisor when he said to hold it back. And this is her. You don't often see these sorts of old pictures. This is the Harvard computers doing some sort of amateur dramatics. She's the one on the left there, pointing at the sky. I think that's quite funny, sort of real insight. Right, so we're going to do one of her experiments. So you should find that somewhere on your table you've got a pair of glasses. If there is not enough for one each, so I do apologise. We might need someone to go up and hover by the lights. Oh, I can see a partner's there. Do you know how to do the lights? So before the lights go off, just use your glasses and have a little look at the lights in the room. You should be able to see an effect. Can you see something going on there? Ooh, and you get a little ripple of excitement, which is nice. Ooh. Okay, so what you're looking at these lights is probably a fairly broad spectrum of colours, yeah? You're seeing a sort of split up rainbow. If you turn your head sort of left and right, you get a nice sort of disco effect going on, which is quite nice. So I don't know what these lights are exactly, they look like they're LEDs, but usually you have quite a broad spectrum of colours. These glasses are basically sort of flat prisms, okay? So they are looking at, that's okay, you can leave them off for now, that's fine. So you're looking through, it's called a diffraction grating, they're very, very fine lines, but they're basically like a sort of prism effect. So it splits up the light into all the colours of the rainbow, or all the colours that exist in that light. So over here I've got a special type of light that has a gas tube in it, and we've got some different gases, and I'm going to challenge you to see if you can work out what the gas is from the light. Alright, so these glasses basically give you a fingerprint of the light, it's a bit like a barcode, that tells you what gas is in the tube. And this is basically the experiment Cecilia was doing with a spectroscopy machine attached to her telescope. She was splitting up the colours of the stars and working out what gases are in the stars. So, the screen will be quite bright, so I'll move it around because it probably works best when you're directly on. But have a look and see if you can spot which colours are coming out beyond the main slit of the light. It looks great here. I feel like I'm in some kind of weird 3D movie. Can you see the colours? Maybe if you can share the glasses with someone who hasn't had a look, I'll swing it back. Can anyone see the slit? Don't look directly at the slit. Look at the colours that come out to the side of the slit. Does that work? Can you see any colours? Yeah. It's a bit dim. Yeah? Come back this side just one last time. So you might get some colours are stronger than the others. Okay, would anyone like to guess from the ones on the screen, which gas do you think that was?
Mercury.
Mercury we have at the front, very fast. Any other takers? Correct, sir. It was mercury. Well done. So you probably would have seen blues, purples, a bit of yellow and some red. I've got another gas, I'll just do one more. This one is quite different, I think. Can you see that right at the back? Is it working? Yeah? Okay, if we could put the lights back up. I like to see faces when I'm talking, so. What gas do you think that one was? Neon! Yeah, that one's easy to spot, right? It's much brighter. Neon gas is particularly good at giving us a nice bright colour, and that's why traditionally neon signs do have neon gas in them. You can make them with other gases, but they're more expensive and they're not so bright. So yeah, neon, you would have probably only seen reds, oranges and yellows, so no greens present. So this is basically, you've just done the experiment Cecilia did, you discovered what stars are made of, and that's what she did. So you've looked at the visible spectrum, the bit in the middle here. You probably know that light comes in lots of different flavours, and the visible spectrum is only a little bit of it. So we're going to move out of the visible spectrum into another region so that we can meet our current Cecilia equivalent. I don't think I said at the beginning, but what I like to do as well as the historic scientists, is link their work to some current scientists so that we can show people that, you know, it's not just history, it's happening right now as well, right? So we're going to move this way. So beyond red, in the visible light, we come to infrared. So we can't see that with our eyes. You've probably heard of it because you can look at things in infrared, and we have cameras that can detect infrared that our eyes can't see. Yeah? So we're going to have a little game of guess the object. All right, you can just shout out what you see if you recognise it. These are pictures taken with an infrared camera. So what you're seeing is not the visible picture, but the heat that's coming off the object. So infrared is a way of sort of measuring heat as well. Okay, here's the first one. Oh no, I forgot. I meant to show you this, because I don't know if any of you like XKCD comic strip, but if you haven't found it, there's a lot in this slide, so I would go away and have a little look after, because there's some quite funny things about the electromagnetic spectrum, which I won't dwell on now, but I just wanted to put it up there because I quite like it. Right, this one. Hairdryer, yeah. But what I love about this is obviously all of this bit here, which is the hot air, normally with our eyes we couldn't see it, right? So this infrared camera gives us an insight into something we wouldn't normally see. And you can see the end of the hairdryer is getting quite hot as well. Correct? This one? A man with... Someone say something? Matches, yeah, man with a match. I like this, sometimes you show it and people say, oh, it's a man with a chili pepper. Wrong use of the word hot, but yeah. Yeah, it is a match, a man holding a match. I like this one because as well as the match being really white and bright, you can see that his glasses are really cool. Not in a fashion sense, but because they don't allow infrared to come through. So glass is actually really good at, usually at blocking infrared light. So obviously telescopes that look for infrared can't have glass like lenses because it would block the signal. I like that. This one? Zebra, yeah. Sounds easy, right? But it's a slightly different zebra, slightly unusual, because on this picture, the white stripes are actually the black stripes of the zebra. Because black absorbs a lot of heat and then emits that heat, and so when you take it with an infrared camera, you get a brighter colour than the black stripes. Zebra. This one? Oh, a space one. Be a smudge slide. This is a picture taken towards the centre of the Milky Way, showing that you get an increase in the infrared heat as you get denser and denser towards the centre of the Milky Way. So that's that one. This one.
Footprints.
Footprints, yeah. I'm just going to move the arrow. Footprints. I love this. This is so cool, right? And police can use this in investigations. If you've got bare feet and you walk across the floor and the police can get there quick enough, they can take a picture of the floor and see the tracks of where people walked. So you leave behind this invisible heat print, which is really cool. And when if you do that with someone who's been sitting on a chair, it leaves quite a nice bum print behind, so it's nice and hot. That is footprints, yeah. How about this one? This is actually what I think infrared cameras should be used for, right? Because I have a dog, and in autumn, I can tell you, with the autumn leaves, I don't know if anyone has a dog, but you'll be nodding if you do, it gets incredibly hard to find the poo, right? You have to pick it up. So I've often thought it would be great, can we have a camera that detects poo in the leaves? That's a dog doing a poo, I think. You don't want to look at my Google search history to find that. And another space one. So this brings us on to our second current day Cecilia. These are the pillars of creation. You may have heard of these. And these are massive dust clouds in space. This is basically the same picture taken with different types of telescope. So in this one, you can see all of the dust and it gives us this beautiful image. In this one, which is taken using an infrared telescope, the dust becomes invisible. And astronomers get a kind of X-ray vision ability where they can look through the dust and see what's behind the dust. Which brings me to our current day Cecilia. And some of you in the room might know Professor Haley Gomez, one of my heroes. She is has some parallels with Cecilia in a way. She was born in Barry, just down the road. She was the first person in her family to go to university. She went to Barry Girls' School, where they did not offer physics for girls. So she had to walk down the road to Barry Boys' School to do physics. She was inspired by a book about Vera Rubin, another astronomer, and she is now a world leader in understanding cosmic dust. How cool is that? So she understands what that dust is made of, what it means about our universe, and she's used infrared astronomy to show us what's hiding behind the dust. She is super cool. And like Cecilia, I don't know if I said this, Cecilia became the first head of department at Harvard, female head of department. Haley's become the first female head of school at Cardiff University and one of the youngest female professors in astronomy. So, she is our local hero, and if anyone asks you for the name of a famous astronomer, you can say Haley Gomez, and she lives down the road, and she's very lovely. So, I'm going to move on to my next scientist. Keep Cecilia in your mind for the vote at the end, okay? My next scientist is Delia Derbyshire. Does anyone know who Delia Derbyshire is? One, two, a couple of people have heard of her. Okay, so she was famous. She studied maths and music at Cambridge University, and she was fascinated by sounds. You might think, what's this got to do with astronomy? Come to that in a minute. She was always into this theory of sound, and she felt that maths and music were a really good combination, which I can understand, and you do find a lot of common ground between the two things. She'd always loved radio because she didn't have many books in the house, and radio was the thing that gave her education. So she had this dream that she might one day work for the BBC. So as I say, she studied maths and music, and then she wanted to apply for a job as a studio engineer, sound engineer, and again they said, we don't employ women as sound engineers, sorry. But the one place she could get a job was the BBC polyphonic radiophonic workshop. So she started working there. Now she grew up in the war, and she was fascinated by mechanical sounds and natural sounds and things that you could kind of create music out of, but that were weird in some way. So I'll give you an example of the kind of thing that might have interested Delia. I don't know if she actually did this experiment, but... So I've got all our favourite toy here, the Slinky Spring, right? And a paper cup. Now, I can't let you all experience it, but the best way to get this effect is to use the strings, and you can have a go at this after if you want. Wrap them around your fingers and put them in your ears, and then drop the Slinky Spring, and you get an amazing sound. It may or may not pick up well on the microphone, but I'll try my best. So this, apparently, is the sound that inspired George Lucas to make Star Wars sound effects. Let's see if we can get it to show you. I quite like it. Have a go close up. It's a very cool sound. So apparently it was that sound that he used and then sort of sampled it and used it in Star Wars. So what she did was she understood, and you've probably seen pictures of sound waves in textbooks. When electronic music began, people were using things called oscillators, and they were just things that made vibrations, and that made the air vibrate. And you could change the shape of the sound wave that you made. So she basically constructed, like from scratch, all these weird sounds that we heard in science fiction and things like that. So it's called Fourier synthesis or additive synthesis, and it's sort of adding up waves from scratch. So she was fascinated by that. She also was an expert in a thing called musique concrète, which is where you made recordings of things like this onto tape, and you spliced the tape and you made loops, which were sometimes small or sometimes went all the way around the room on a tape machine, and that's what created what we call a loop, you know, music. But it was an actual physical loop. You used to have to make them by cutting tape. And I'm old enough that when I did sound engineering, that's how I used to make music concrete as well. Now it's a lot quicker, but there's something satisfying about it being a physical thing, and she did some of that. Anyway, she created one of the world's most famous theme tunes, and this is where the space link kind of comes in. So a composer called Ron Grainer wrote the theme tune originally of Doctor Who, and he recorded it, and his style was very much the 1970s kind of big band TV theme tune. So this is what it would have sounded like without Delia. If I can just get this to just go. Oh, funky. Wait for it. And let's go. Okay, that's far too much fun, right? I quite like it, actually. I do like Delia's version, but when I found that, a DJ friend I've got said, thanks for finding that, that's going in my next set. So, but it originally didn't sound like that, and you'll be familiar with when I play the next one with how it did sound. But what I'm going to do is mix this up with the current Delia Derbyshire person and show you something that links to them whilst I play, I hope, the Doctor Who theme tune for you. Woo! Well, like your excitement, contain it. Okay, so I'm going to be, I'm not blowing my own trumpet, but I'm going to put myself in the realm of being the modern day Delia Derbyshire, because I studied physics and music at Cardiff University, and I am a physics and music and sound geek. And I discovered this instrument called the theremin when I was a student, and it's cool. Has anyone heard of a theremin? Yeah, okay. So in my final year project, I tried to build my own theremin, right? It was a complete disaster. This one is not that one. I bought this one. I think I had a maximum difference in note of about a quarter of a semitone. It was really not good. That's science for you, right? Okay, so I'm going to try. A theremin works by having two aerials. This one you can probably see, the one sticking up, and a flat one on the box, which is you probably can't see. So one controls the pitch and one controls the volume. So it's an instrument completely hands-free. You don't touch it at all. You just move in the air. And when it was invented, Leon Theremin, Russian inventor, said, this will empower everyone, no matter what their skills are, to become a musician. Whereas in reality, it's about the hardest instrument you could have, as there's no strings or buttons or anything. Okay, but I will try for you. Let me just see if it's still in tune. Bear in mind, I've been trying to learn this damn instrument for about 22 years, right? So go easy on me, I'm not good. All right. So I'm going to try and put the Doctor Who backing track on, the actual one. And there was a myth for a while that Delia played the theme on a theremin because the sound effect is quite similar. She didn't, but it does sound quite good with it. So, well, I say good. Manage your expectations. Funny, and this is the creativity of scientists, right? And this is the ultimate physics, music, woman's area of instrument, the theremin bra. I do not have one. I'm not intending to get one. But how creative! This is amplitude. This is okay, moving on. So yeah, I am a complete physics music geek. So when I got to go to the Palace for my MBE, thank you for that drop, Tony, I wanted to get a dress that would sum up my passion for sound. And obviously, you look for science dresses and you tend to get space dresses like this. And there was DNA dresses, but there was nothing to do with sound. So I thought, I'm going to make something then. If it doesn't exist, I'm going to make it. So I got a friend to help me turn the sound waves of my kids shouting "Science Made Simple" into a machine, an oscilloscope, which turned it into an image, which we printed to a fabric, which a friend of mine who's an engineer then made into a dress. So this dress actually has the sound wave that comes from my kids' voices. And I thought, oh, it's really special, a bit soft. Oh, thank you. Thanks for following up on that. Little fans at the back there. So I felt good when I went that I had something unique. And Prince Charles gave me mine, King Charles now, and he didn't even notice the dress. Can you believe that? I'm so disappointed. Anyway, I am a bit of a physics music geek. I don't do sound engineering now, but I do still love all things music and tech and things like that. If you want to find out more, I'm not going to play this, you can look for this video, which is a short 6-minute video all about Delia Derbyshire that I presented for the British Council. You can find that. I'm not going to play it. I'm going to move on to our last person. Right, a bit of interaction. Anyone know what the first animal in space was? Yep.
Monkey.
A monkey? We think monkey. Any advance on monkey? Yeah, at the back?
Fruit flies.
Exactly, thank you, sir. It was fruit flies. 1947, before the dog and the monkey, NASA sent a box of fruit flies up to space and they recovered them safely. I can't even bring myself to talk about the dog because it's just too sad. So 1947, first man in space, easy. Yuri Gagarin, did someone say? Yeah, Yuri Gagarin, there he is, 1961. I bet someone will know this. First woman in space. Over here.
Can I redeem myself?
Yes.
Valentina.
Thank you, Valentina Tereshkova, 1963. Beat the Americans by 20 years. It was 20 years before Sally Ride, the American astronaut, went into space. So my final hero, my final Xtra Factor contestant is Valentina Tereshkova, first woman in space. And she had this nice quote: "A bird cannot fly with one wing. Human space cannot develop any further without the active participation of women." Here. And in Life magazine in the US, they reported this, and they were very much taking it as a kind of Russian win for equality. They really kind of got into the fact that she had beaten all of the sort of, barriers and beaten all of these things that got in the way in terms of the US space program. So it became quite a political thing, which is quite good. And particularly like this headline: the US team is still warming up on the bench. Sporting thing. So she was the first woman in space. She was only 26. She hadn't done any formal education. She had secretly been taking skydiving lessons, not telling her family. She'd done about 20 odd skydives, and that was what got her into the space program. She didn't complete any education until she came back from this trip to space. So she was selected purely because she was the best person with a parachute. But yeah. My modern day equivalent is Peggy Whitson. Anyone heard of Peggy Whitson? Yes, Holly has. Here's another name for you then, another name. She is still going into space at the age of, she's more than 57 now, I think. And she has spent the most time of anyone in space by a woman. The first woman to command the International Space Station. She's been the oldest woman in space. She's done over 60 hours of spacewalks, which puts her about 7th in the world, I think. And she is widely regarded as one of the most accomplished space explorers in history. She was also the first chief of astronauts at NASA, first female to take that role. And she is now working for Axiom, who are a private commercial space company, who are working on building the first commercial space station. And she quite recently went up to space again as a commander for them in a private capacity. So to finish my talk, before we have the vote, I'm going to try and explain to you the challenges of living in the space station without gravity. Okay, so obviously one of the problems if you spend extended time in space is that you haven't got the forces of gravity, and that can cause all sorts of problems to your body. So you might have seen in science fiction films that they have these concepts of building a rotating space station that would generate kind of perceived gravity that isn't real. So by spinning the space station, as we'll see in a minute, you can generate a kind of false force that acts like gravity. So if you're the person walking around the edge of this huge space station, like these little ladybirds, don't ask me why they're ladybirds, you feel a force pushing your feet to the floor, so it's like a fake gravity. The problem with that is to get it working so that it spins at a speed that doesn't make all the astronauts perpetually sick, this would have to be 200 metres across at the moment. So that's 2 football fields wide, and we just have not got any technology that can get a craft that big kind of constructed in space yet. But that is the theory. So just for fun, and just to see if I can still do it. I've got a cup of water here, which I'm going to put on my spinning space station. Ooh, I like a bit of jeopardy. I hadn't done this for years until last night, another practice again. Who knows? So in theory, at the moment, gravity is holding the cup down and the water down. If I turn the cup upside down, gravity would pull the water out. But if I spin this tray fast enough, we will create a force that emulates gravity and appears to push the water down towards the tray, even when it's up here. Do you think I can do it?
Yeah!
I'll give you a clue. Once it's started, it's not so bad, but it's stopping that's quite tricky. So I might just have to stay here all night. Thank you. That is pretty much me. I'm sorry I went a little bit longer. Let's just have a quick vote in the room to see what you thought of those 3 Xtra Factor candidates. So cheer and clap as loud as you want for your favourite, and let's just see who we think it is. So first up we had Cecilia Payne-Gaposchkin! very popular. Second up, we had my personal favourite, Delia Derbyshire. And last but not least, the very first woman in space, Valentina Tereshkova. Okay, I'm going to call, I think it was Cecilia. What do you reckon? Yeah. It was close though, and I like that you loved them all. Remember them all and tell them to other people so that we can get some other answers other than Marie Curie next time. Thank you very much.